The most terrifying thing about the night sky isn't the darkness itself. It isn't the black holes lurking in the shadows or the vast, crushing distances between galaxies. The most terrifying thing is memory. Because when you look up, you rely on a fundamental comfort of existence, the belief that the universe is permanent. You believe that the stars you see tonight are the same ones your ancestors used to navigate the oceans thousands of years ago. You believe that if a mountain is there today, it will be there tomorrow. We call this object permanence, and it is the bedrock of our sanity. But what happens when the universe begins to gaslight us? What happens when our most powerful telescopes look at a specific coordinate where a massive star or a planet or a galaxy should be, and find absolutely nothing? No explosion. No debris field, no fading ember, just a perfect, impossible silence. For the last few decades, a quiet panic has been spreading through the astronomical community. We are finding holes in reality. We are finding that the cosmos is not a static painting, but a place where things, massive things, are being erased. Today, we are going to walk through the evidence. We are going to look at 10 specific cases where the impossible happened. From the edge of our own solar system to the furthest reaches of deep space, we have to answer the question that keeps astrophysicists awake at night. Where did they go? Let's begin where we feel safest, our own backyard. We tend to think of our solar system as a finished product. The planets are settled, the moons are accounted for. But in 2013, the Cassini spacecraft, so arguably one of the greatest robotic explorers we have ever built, sent back data from the rings of Saturn that didn't make sense. Saturn's A-ring is a chaotic place, a river of ice and dust. But amidst that chaos, Cassini spotted order. A bright, distinct clump of material began to gather at the ring's edge. It was massive. It was coherent. It was the birth of a new moon. The scientific community was electric with anticipation. We named it Peggy. We prepared our instruments to watch Peggy detach from the ring and begin its lonely life as a new satellite of Saturn. It was supposed to be a triumph of observation. But then, the impossible happened. Peggy didn't break apart violently. She didn't spiral down into the planet's atmosphere. She simply dissolved. One moment, a moon-sized object was forming. The next, the data showed nothing but the standard background noise of the rings. It wasn't an explosion. It was an erasure. This event forced us to coin a new, somewhat unsettling term, ring weather. It suggests that in the outer solar system, the line between an object and a ghost is thinner than we thought. Peggy wasn't a solid body. She was a transient phantom, a collection of matter that mimicked a moon before the universe decided she shouldn't exist. It was our first warning. In space, seeing is not always believing, but at least Peggy was small. What happens when we lose something that should be indestructible? Comets are the ancient travelers of our system. They are dirty snowballs, miles wide, holding the history of the solar system's formation. When a comet dies, it is usually a spectacular, violent event. As they approach the sun, the heat tears them apart. They sublimate, screaming out gas and dust, often breaking into smaller rocks that continue on their path. We know what a dying comet looks like. It looks like a mess. Yet recently, astronomers tracked a bright, healthy comet diving toward the sun. We calculated its trajectory. We prepared to image its tail and its fragmentation. We waited for it to emerge from the sun's glare. But nothing came out. The comet didn't just break up, it vanished, completely. There was no dust cloud, no rocky nucleus, no trace of ionized gas. It was as if the object had been wiped from existence the moment it touched the sunlight. The leading theory is that it was a fragile comet, one that vaporized entirely. But the lack of residue is haunting. It challenges our understanding of what these objects are made of. Was it truly a comet? Or was it an interstellar visitor composed of materials so volatile that our sun simply evaporated it into nothingness? As we leave the solar system, the scale of these disappearances grows from miles to light years. The mysteries stop being about rocks and ice and start being about the fundamental forces of physics. Deep in the cosmos, we have been listening to a phenomenon known as fast radio bursts, or FRBS. These are high-energy screams of radio waves that last only milliseconds, but release more energy than our sun does in a century. Most of them are one-off events, a flash in the dark. But one source was different. It was repeating. It pulsed with a rhythm. It was a cosmic heartbeat echoing through the void. A repeating signal is the holy grail for astronomers because it implies a stable source, a spinning magnetar, a neutron star, or perhaps an artificial transmitter. We trained our ears on it, recording the pattern, building models to explain the engine driving it. And then, silence. The signal stopped. It didn't fade out slowly, which would suggest a star losing energy. It didn't become erratic. It simply cut off. If this was a natural machine, like a magnetar, where is the residual radiation? And if, for the sake of argument, this was a signal from a civilization, why did they stop broadcasting? Did their machine break? Did they move? Or did they realize that someone was listening and decided to go dark? The silence that follows a signal is always heavier than the signal itself, but sometimes the universe doesn't just go silent. Sometimes it plays tricks on us. Let's talk about the zombie star. In standard stellar evolution, a star has a life cycle. It burns, it expands, it explodes, or it fades. It is a linear path. But we have observed a massive star that defies this linearity. This star faded. It dimmed until it was practically invisible to our instruments. For all intents and purposes, it had died. We wrote it off, and then, years later, it turned back on. It returned to its original brightness, as if nothing had happened. This is not how nuclear fusion works. You don't just pause a star. The implications here are staggering. If the star didn't actually change, then something must have happened to it. Was it swallowed by a cloud of interstellar dust so thick and cold that it blocked all light? Or is there something orbiting that star? Something massive and dark and artificial that eclipsed it for a period of years before moving on. We are left with a star that refuses to stay dead, and we have no math to explain why. This brings us to a name that sends shivers down the spine of every rigorous astronomer, Tabby's star. You might have heard of it. It's the star that broke the internet a few years ago, but the context is vital. When we look for planets, we look for dips in light. When a planet passes in front of a star, the light dims by maybe 1%. It's a tiny, rhythmic wink. Tabby's star didn't wink. It plummeted. It lost nearly 25% of its brightness, and it didn't happen in a neat, periodic rhythm. It was chaotic. The light curve looked like a jagged mess. Dust doesn't do that. Comets don't do that. The only model that mathematically fit the data was not a natural phenomenon. It was a structure. This birthed the most controversial hypothesis in modern astronomy, the alien megastructure. Specifically, a Dyson swarm. Imagine a civilization so advanced that they have outgrown their planet. They need more energy. So they begin to dismantle their solar system to build massive solar collectors around their star. As they build, they block the light. We aren't seeing a natural dimming. We are seeing the shadows of industry on a galactic scale. The dimming has since stopped, and the star has returned to normal. Does that mean the theory was wrong? Or does it simply mean that the construction project is finished? The further we look, the more the logic of the universe seems to fray. Consider the case of Fomalhaut b. This was supposed to be one of our greatest achievements, the first time we directly imaged an exoplanet. We didn't just detect it with math, we took a picture of it. We saw a bright, warm dot orbiting a distant star. We tracked it for years. It was in the textbooks. It was real. And then it vanished. When Hubble looked back, the planet was gone. There was no collision debris, which would have been bright and hot. There was just empty space. How does a planet die without a trace? The current explanation is that Fomalhaut b was never a planet at all. It was a cosmic cloud, a rare, dense gathering of dust that mimicked a solid world perfectly, fooled our best scientists, and then dispersed into the wind. It forces us to ask, how many other planets in our catalogs are just ghosts waiting to dissipate? But at least Fomalhaut b faded slowly. Some things disappear in the blink of an eye. There is a category of object we call fast blue optical transients. It's a dry, technical name for a terrifying phenomenon. Near a distant galaxy, we witnessed an explosion. It looked like a supernova, shining with the power of millions of suns. But a supernova takes weeks to cool down. It leaves behind a nebula, a black hole, a pulsar. It leaves a scar. This object appeared, flared up, and then vanished completely in a matter of days. It was clean. It was efficient. It left no thermal footprint. Astronomers compared it to a shapeshifter. We don't have a model for a star that can detonate and clean up its own mess so quickly. It suggests that there are violent, high-energy processes in the universe that happen so fast we have missed them for centuries. We are only just now opening our eyes wide enough to catch the flash. The speed of these disappearances is what makes them so unnerving. In the 1950s, we were taking photographic plates of the sky. In one specific instance, a plate captured a bright, distinct star. Less than an hour later, the same telescope took another picture of the same spot. The star was gone. Stars do not die in an hour. Even if they collapse, they emit energy. To vanish in 50 minutes implies a mechanism that is either incredibly catastrophic or directed. Was it a glint of light from a rotating mirror in deep space? A laser focused on Earth for a brief second? Or something that simply blinked? The transient mystery suggests that the night sky is alive with activity that is too fast for us to comprehend. We also have to talk about the rocks that should be there but aren't. We track asteroids for a very selfish reason. We don't want to go the way of the dinosaurs. We are very good at it. We catalog their orbits. So when a massive asteroid, one we had been tracking for its brightness and stability, suddenly disappears from our view, it is concerning. This wasn't a calculation error. The object was there, and then it wasn't. No dust cloud from a collision. It implies that solid matter in our universe might be more fragile than we believe. Or perhaps we don't understand the gravitational highways of the solar system as well as we think we do. If a mountain-sized rock can slip away into the dark unnoticed, what else is hiding out there? But all of these anomalies, the disappearing moons, the blinking lasers, the zombie stars, they all pale in comparison to the final, most chilling mystery. Because this isn't about one object, it is about a census of the galaxy. And the numbers don't add up. This is the story of the VASCO project. VASCO stands for Vanishing and Appearing Sources During a Century of Observations. The premise was simple and brilliant. A team of scientists took old star maps from the 1950s, physical glass plates used by naval observatories, and digitized them. Then they wrote a computer program to compare those old maps with modern, high-resolution sky surveys from the 2000s and 10s. They were looking for changes. They expected to find a few exploding stars, maybe some moving asteroids. Instead, they found the missing. The project identified over 100 stars that appear clearly in the 1950s data, but are completely, utterly gone today. Let that sink in. 100 suns. We have checked for supernovae. If they had exploded, the gas clouds would still be glowing today. We have checked for slow cooling. They aren't there. They simply ceased to exist. How do you explain the silent death of 100 stars? The most scientifically conservative theory is actually the most terrifying for astrophysicists. It is called the failed supernova. The idea is that a star can be so massive, so incredibly heavy, that when it reaches the end of its life, the core collapse is instant. It doesn't bounce back and explode. It simply collapses directly into a black hole. It swallows itself. One moment there is light, the next, there is a hole in reality. It is a silent, instant death. If this is true, it means the universe is far darker and more violent than we thought. But there is another possibility, one that we discuss only in hushed tones. If we look at these 100 missing stars through the lens of the Fermi paradox, a different picture emerges. We know that any advanced civilization will eventually need more energy than their planet can provide. They will need to harvest their star. We have theorized about Dyson spheres, shells that wrap around a star to capture 100% of its output. To an outside observer like us, the construction of a Dyson sphere would look exactly like a star slowly vanishing. Or, if they have the technology to deploy it quickly, a star blinking out. Are we looking at a graveyard of failed stars? Or are we looking at a map of galactic expansion? Are we watching the lights go out one by one because someone else is flipping the switches? The VASCO project hasn't just given us a list of missing stars, it has given us a list of coordinates to listen to. So, where does this leave us? These 10 mysteries force us to confront a humble, perhaps uncomfortable truth. For centuries, we have looked at the sky with arrogance. We mapped the stars and claimed we understood the laws that govern them. We thought the heavens were a clockwork mechanism, predictable, reliable, eternal. But the universe is not a clock, it is a chaotic, shifting ocean. Maybe these vanishings are evidence of new physics, ways for matter to be destroyed or hidden that our mathematics haven't even begun to describe. Maybe they are cosmic mirages, proving that our eyes and our telescopes are easily fooled by the play of light and gravity. Or maybe, just maybe, they are evidence that we are not the only ones home. The disappearances tell us that the story of the universe is still being written and pages are being torn out before we have a chance to read them. The next time you walk outside at night, take a moment to really look at the stars. Don't just glance at them. Focus on them, cherish the light, because we now know that out there in the infinite dark, the only guarantee is change, and some things once lost are never found again. Keep looking up, but remember to blink before it's gone.